All right, hello everyone. Today I'm going to review with you the different types of factoring methods that you either see in an Algebra 1 and 2 class. Okay, so again, I do in this video, we'll go through Algebra 1 first and all the different type of factoring you're going to see. And then in the middle of this video, I did insert a slide separating the difference between Algebra 1 and Algebra 2. So if you're an Algebra 1 student and you see what you need to see, you can stop the video. But if you're an Algebra 2 student and you need to go a little further with this, just please keep watching. And again, just do what you need to do to hopefully this video will help you with all the factoring methods that you're going to see. Okay, so let's get started. All right, well that's kind of blurry, but that's our problem. Okay, so we're starting with greatest common factor, GCF. Okay, let me kind of pull this over here. Okay, so we're going to start with the greatest common factor. We have 3x cubed plus 12x squared minus 6x. So again, I ask you to take out the greatest common factor, or in English, basically it's what do all these pieces share that I can divide out of all the problems, or all the pieces, sorry. So, in looking at my numbers here, regular numbers first, I have a 3, a 12, and a 6. So all these numbers are divisible by 3. So we're going to kick out the 3. Now when we're doing this, it's like we're dividing, okay? So I'm going to take 3, divide it by 3, I get 1. 12 divided by 3 is 4. Negative 6 divided by 3 is negative 2. Okay? Now for the hard part, the x's. Okay? Now x cubed says I have 3 x's. X squared says I have 2 x's. And x to the first says I only have 1. So we're asked, how many x's can I take out of all the pieces without making one negative? Or, going over the limit, as they say on The Price is Right. And again, if I look at this, well, 1x, 1x, 1x. So I can at least take out 1x. Okay, kind of like how my students will say it is, we're going to be looking for the lowest amount of x's here. Okay, so I'm going to kick out an x. So again, that kind of makes this first x go away, this x here go away, and this go away. So we see what's left. So here I have 2 x's left, so it's going to be x squared. Here I've got 1x left, so that's x. And here I have no x's left, so there's nothing there. Okay. So if I were factoring this, this would be 3x parenthesis. Now, yes and no. Again, if you want to put the 1 here, you can, but it's understood if I just write x squared, that the 1's really there, plus 4x minus 2. And that's how we factor using greatest common factor. Okay? Probably the easiest thing to do when you're factoring. All right, now, next thing we do is we're going to factor using what I call PS2. Okay, so we're going to start with the one on the left. Now again, PS2 works when it looks like when we have nothing in front of x squared. So, in English, there's a 1 hiding here. Okay, so we're going to do that only when there's an x squared there. Okay. Stop it. Okay. All right, so let's get started. Now we have 3 pieces of PS2, the P, the S, and the 2. Now, the P stands for product. And with a trinomial, your product is always the constant piece, or the piece on the end. So this is your product, including its sign, so it's plus 8. And yes, I include the sign with it, because it's going to help me later on figure out what I'm supposed to be doing with this. Now the S component is this piece right here. Okay, and including the sign, my sum is negative 6. All right, now for the hard part of the PS2. Okay, you need the 2 numbers that multiply to give you the 8 and will also give you negative 6 when you add it. So kind of the way I always explain this to my students is, think of it if you will. You have 2 numbers that multiply to give you 8, so start thinking about the multiples of 8. There's 1 and 8, 2 and 4. That will add, so that's why I say include the sign, and those two numbers will give you a 6. Not -6 right now. I'm not worried about this right now. We'll come to that later. So what two numbers multiply to 8 but add to 6? And we look, well, the 4 and the 2 do that. So 2 and the 4. Now, here's where the sign here's where the 6 the negative part comes in. I need these two numbers to add together to give me -6. Well, right now, if I did a +4 and a +2, that gives me +6. That's not going to work. Okay. If I did a +2 and a -4, that gives me -2 if I add them. That's not going to work. If I did -2 and +4, okay, that gives me +2. So the only way this is going to work is if I do -2, -4. And that will give me the -6 I need. So now that we have our numbers, okay, let's do our quick check. Now the PS2 has a great built-in check. Takes 3 seconds to do. So we start. If I take -2 and multiply it with -4, okay, do I get +8? And the answer is yes. So I'm good there. Oops. If I take -2 and add -4, do I get -6? The answer is yes. So we're good there. So since I said yes to both, we're ready to go. So we're going to take our x's. The two x's in the front make up the x squared. And then you just drag these guys in. So you have the -2. Drag this one in. We have the -4. And there's your factors. Okay. Now, the one on the right here, there is a slight difference, so we have to be ready for it. So I wanted to show it to you. PS2. Okay. So let's get started. My product this time is going to be -40. My sum, or subtraction result in this case, is going to be +6. Okay, so we have to think, what two numbers multiply to 40 but subtract to 6? So again, if you're stuck and you need a list of factors, 1 and 40. Well, no, that subtracts to 39. 2 and 20. No, that's 18 if I subtract. 3 and, well, 3 and nothing works, gives you 40, that's no. 4 and 10. Will that subtract to 6? Yes, it does. So here's our numbers. So 4, 10. Now my signs to give me +6. Now we have to be careful. So let's do, okay, so I need +6. So that means I'm going to have a +10 and a -4. So to do my check, let's double check this. Is -4 times +10 -40? Yes. Is -4 plus 10 +6? Yes. So we are ready to put this all together. Okay, so we started with x squared, so it's going to be x and x here. And we drag this in, so -4 plus 10. Okay, and there's your answer. Now again, many students have asked me, well, gee, does it matter? Say I did x plus 10. They did the x plus 10 first and then did the x minus 4 second. Is that still correct? The answer is yes, that is still correct. Okay, so let's move on. All right, next one, difference of squares. Okay, now when we do difference of squares, okay, that means that the first piece is a perfect square, the last piece is a perfect square, and we have a minus in between the two pieces. Difference means to subtract of squares, meaning the two pieces here are perfect squares. Okay, so when we do something like this, okay, I usually teach this two different ways. Okay, now the first way I'm going to show you is using the PS2 method. Okay, Now, with the PS2 method, okay, what we're going to do is notice how the middle term is missing. If you remember what we just saw in the PS2 slide, we had 3 pieces. But notice this one only has 2, so we're missing where the regular x is. So I'm going to do x squared plus 0x minus 16. Because the reason why they didn't list this x here is because it was 0, and no point listing the 0. Okay, so now let's go to our PS2 process. So our product is going to be negative 16. The sum in this case is going to be 0. And then you have your 2 numbers. So now, knowing this, knowing your sum is 0, that tells you 2 things. 1, the numbers have to be exactly the same. So if you're running your factors, 1 and 16, 2 and 8, 4 and 4, you need these things to be 0. So the only way you're going to get 0 is if the numbers are the same. Oops. Okay, so that's part 1. So you know it's going to be 4 and 4. Now, thinking of this mathematically and logically, most of you probably already see what's going to happen, but I'm just going to be safe. You need these to be 0. So how do I get 0? Well, one's positive 4, one's negative 4. So when I do this, positive 4, negative 4. So x plus 4, x minus 4. And there's that one. All right, so that's the PS2 method. Now, with the next one is just knowing what you have, and knowing that you have squares. So for instance, 9x squared. 9's a perfect square, x squared is a perfect square. 25 is a perfect square. And you have a minus sign. Okay, so having all these pieces in place means you can go skip right to breaking this down into its perfect square roots. But when you do this, what you put in one parenthesis, we're going to put in the other at the same time. So for instance, 9, you're going to break down as 3 and 3, because 3 times 3 is 9. Okay, then it comes to x squared. Well, what times itself gives you x squared? Well, that's easy. That's x and x. Then it comes to the 25. Well, what times itself gives you 25? Well, that's easy. That's 5 times 5. Now, for the trickiest part of this whole process is your signs. To give you a negative, that means one has to be positive, the other has to be negative. And there you go. Kind of the faster way to do it if you know your perfect squares. Okay, so there's that one. All right, moving on to the next one. All right, factoring with slide method. Now, with this method, again, some teachers, I'm going to warn you now, like this and they'll teach it. Other teachers do not like this method and they prefer to use something else. So if your teacher uses the factor by grouping method, go to the next slide. Or if you'd like to hang out here and just see how the slide method works, you're more than welcome to do so. Okay. All right, so here we go. So let's start with this. All right, so to do the slide method, again, first thing we do when we factor, we look for greatest common factor, which I don't have. So let's multiply. We're going to multiply the first coefficient with the last coefficient. We are not using the x. So 3 times 4, positive 12. Okay. Now at this point, we're going to put in the slide. So I split kind of between the 3 and the x squared, and we cut off this positive 4. At this point, this thing's completely worthless. Okay. So from here, we're going to be looking at this. We're going to do our mini PS2. So again, our product is going to be what we just multiplied. So the positive 12. The sum is going to be positive 8 right here. So the two numbers multiply to 12 but add to 8 are 6 and 2. 6, 2, and both are going to be positive. Okay. So we put up our parentheses. Okay, so we're going to have our x plus 6 x plus 2, like so. But now, here's the catch of the whole slide method. We have a rhyme that says, since you did the slide, you have to divide. And we're going to divide by the lead coefficient. What started it all is the 3 out in front. So you're going to divide both pieces by the 3's and see if you can reduce it. Okay, in this case, 6 over 3 can reduce to 2 over 1, or just 2. So this is going to be just x plus 2. Now here, 2 over 3, I can't do anything with reducing wise, so what we're going to do is we're going to take the 3 and we're going to scooch that in front of the x. So you're going to have 3x plus 2. And there it is. All right. Let's take a look at the other one. So let me split this in half here. Okay, oops, hey. Okay, so let's start with this one. Now again, we're going to start, can I take GCF out of this 2x squared minus 13x minus 7? No. So first thing we do, let's multiply front to back. So 2 times negative 7 is negative 14. Okay, so now I'm going to put in my slide. I'm going to completely ignore this now. I don't need it anymore. So x squared minus 13x minus 14. So we're going to do our mini PS2. Product is negative 14. Sum is going to be negative 13. So my two numbers that multiply to 14 but subtract to 13 are negative 14 and positive 1. Okay, so we're going to have x minus 14, x plus 1. Okay, so there's that part. But now, don't forget, since we did the slide, we have to divide. Okay, so when I put this together, I can reduce 14 and 2. It's going to be x minus 7. Now 1 over 2 I can't reduce, so I'm going to take the 2 and I'm going to scooch it in front of the x. So I'm going to have 2x plus 1. And there's that one. Okay, so that's the slide method. And now let's review if your teacher doesn't like slide method, or again, you can see these same problems done using what factor by grouping. All right, so taking a look at factor by grouping, okay, what we're going to basically be doing is we're going to start the same way as you would use the slide method we did on the previous slide. We're going to multiply front to back, but then we're going to, instead of doing a mini PS2, what we're going to do now is we're going to split the middle term into two pieces and then group it all up and break it down that way. Okay, so let's get started. So first thing I look for, let's look at the 3x squared plus 8x plus 4. And we're going to factor this. So I look for GCF first, which I don't have. So I'm going to start by multiplying front to back. So I'm going to scooch this to this. I'm going to multiply it. So we use 3, not the 3x squared, and we're going to times by positive 4 and get positive 12. Now, then what we're going to do with grouping is we are still going to use a PS2 here, okay, where the product is going to be positive 12. The sum is going to be a positive 8, okay, and my two numbers, obviously two numbers that multiply to 12 but add to 8 are going to be positive 6 and positive 2. But now with slide method we put it in the parentheses and go. With grouping method what we're going to do is we're going to reset this problem right here, but we're going to split this apart because I know 6 and 2 is going to give me this 8. So we're going to do 3x squared plus 6x plus 2x from these two pieces here, and then the plus 4 in the end. Okay, now what we're going to do is we're going to split this up. We're going to combine, we're going to group together the first and second piece and the third and the fourth piece. Now by doing this, what we're going to be doing, we're going to do a setup like this. where we're going to be looking to take out GCF. So from this first parenthesis, my greatest common factor, it can take out a 3 and I can take out an x, leaving me x plus 2. Okay. Now, then we're going to look to the second parenthesis and do the same thing, but the catch is this parenthesis and this parenthesis have to match. If they don't, then you have to go back and fix something if something's wrong. So let's see. So I can take out a positive 2, and yes, you want to include the sign because it's going to be helpful later. Okay. So x plus 2. All right, now we're going to put this all together. Now, how I describe it to my students is the first parenthesis is the parentheses we have. Now, you're not going to write it as squared because technically what we're doing is we're going to take the greatest common factor out of this huge sentence right here, which is this guy right here and this guy right here. In English terms, the best thing to do is say this is, I'm just going to take everything in the parentheses and just put it as 1. So x plus 2. Not x plus 2 squared, just x plus 2. And then I can get rid of this. Second parenthesis is all the garbage left over on the outside of this thing. So that's your 3x, and that's your plus 2. So 3x plus 2, and there it is. Okay. So let's take a look at the next one. I'll kind of move this over a little bit here. Maybe shrink it if I can. There we go. So I have room to work on the other one, because I kind of overlapped a little bit here. All right, so let's split this. There we go. All right, so let's take a look at this next one. So again, first thing I look for in 2x squared minus 13x minus 7 is greatest common factor. Can I take out the GCF? The answer is no. So let's start multiply front to back. That gives me negative 14. Okay, now we're going to do our PS2. Product, negative 14. Sum, negative 13. Two numbers that do this are negative 14 and positive 1. Okay, so let's reset our equation. We're going to split the negative 13x with these two pieces. So you're going to have 2x squared minus 14x plus 1x minus 7. All right, now let's group this thing up. First and second piece, third and fourth piece, line, bracket, line, bracket. Okay, so let's see. What can I take from the first grouping here? I can take out a 2x. That's going to be x minus 7. All right, now let's be careful with this next one. From x minus 7, what would I need to take out to make this look like this? Well, you'd say nothing, so I don't put anything on the line, right? Wrong. Remember, what we're trying to do here is take out GCF, meaning you're dividing here. So what would you divide out of a piece that doesn't affect it? You'd divide by 1. So this would be a positive 1. And that would leave you the x minus 7. All right, so let's put this all together. My first parenthesis is the parenthesis stuff. So that's going to be x minus 7. Second parenthesis is going to be all the garbage left over on the outside. So that's going to be a 2x plus 1. And there you go. So that is how you factor by grouping. All right, now at this point, like I said, Algebra 1 students, if you want to keep watching to see what you're in for next, or maybe your teacher's taking you a little further, great. If not, if you're in Algebra 2, you're going to need to keep going because we're going to start going into the more fun stuff that you see in Algebra 2. All right, so one of the first things we talked about is factor by grouping, okay? Or correction, factoring cubics, sorry. One of the first things we talk about is cubics, okay? Now, for those of you who have had me before, and hopefully you've seen the lesson, if not, I'll explain it, is we have something called what I call the cubic stance, okay? Now, to do the first part, you're going to have two parentheses. A common misconception with a cubic is that you have three parentheses. And the answer is no. We still only have two. Now, the first one, the first parenthesis, is the cube roots of the problem. Okay, the first parenthesis is the cube roots of the problem. So we take a look. Cube root of x cubed, x. Cube root of 27 is 3. All right, so now, here's where we get fun normally, but again, I don't have a good video thing to do my cubic stance with, so I'll just explain it. So what we're going to do, again, this is going to be my first piece. This is the first piece. This is my last piece. And that's going to come in handy when we do this. Okay, so we start. The first thing is to square the first. Okay, the first term piece of the second parenthesis, square the first piece. So we're going to take x and square it. So we get x squared. Then we do the last piece. We're going to square the last. Okay, so I take 3 and square it, I get positive 9. Now for the middle, this is the trickiest part of this whole thing. You're going to multiply the first and last and then change its sign. Most people refer to this as SOAP. Okay. So here we go. Multiply and change the sign. So what I mean by this is, here, let me get rid of this. Okay. So what we're going to do is multiply the x and the 3. So 3 times x is 3x. So that's this part. Multiply the first and last. Then we're going to change its sign. Since it's positive 3 right now, we change it to negative 3. If it were negative 3, we change it to a positive. And that's what goes on that line. So minus 3x. And there you go. That's a cubic. All right, so I'm going to do another example so you guys can see that. So again, first things first. Come on. Oh, I shut the pen off. Try that again. Okay. So we have our two parentheses. Okay. So we start. Cube root of 125, 5. Okay. Cube root of x cubed is x. Cube root of negative 8, negative 2. So that's the easy part. All right, so here we go. Square the first. 25x squared. Square the last. Negative 2 squared is positive 4. Okay, multiply. So 5x times negative 2 is negative 10x. And change its sign. So it was once negative 10x is now positive 10x. And there it is. There's your cubic right then and there. Okay. All right, let's move on. All right, factor by grouping. So again, watching the earlier video on how to factor by grouping. Okay, so instead of 3 pieces, we have 4. So we're like midway through the factor by grouping process of a trinomial. Okay, so like we did, we're going to group up. First thing I would do actually, and let me get rid of that, is I would check my exponents. Make sure they're in descending order. So 3, 2, remember this is 1, and then there's 0 here. This is x to the 0. So since I have descending order, I'm good to go. If, again, you do not have descending order, you may have an issue. So make sure you put it in descending order. All right, so now at this point, let's group up first and second piece, third and fourth piece. So we're going to line, bracket, line, bracket. All right. So first thing we do, we're going to take GCF out of this first grouping, and it's just x squared. So you have x minus 3. Now be very careful. We need to take a GCF out of this, but this parenthesis, when I do it out, needs to look like this. So what can I take out? Well, I can take out a negative 16. Kind of like a trick I teach my students with something like this is to see if it works, is take this number and divide it by this, and whatever answer you get goes here. So 48 divided by negative 3 is negative 16. Okay, and then just make sure it works for here too, which it will. So that'll leave x minus 3. All right, so now let's put this together. Okay, so x minus 3, that's my common piece. So we're going to have the x minus 3. Okay. Now, all the garbage on the outside, that's what's left over. So that's the second parenthesis, is x squared minus 16. Now, one thing we have to be careful of is we need to look in the parentheses and make sure that if I see exponents in a leftover parenthesis, I have to double check to make sure I can't factor any further. Okay. Now, x minus 3, there's no exponents in it, so I'm good there. But x squared minus 16, I have a perfect square with a minus sign. This is difference of squares. Makes kind of a smiley face, huh? All right, so let's do that up. So x squared's perfect square root is x and x. 16's perfect root is 4 and 4. Minus and plus. Okay. Now, since I can't go any further because I don't have any more exponents in these parentheses, we're good. So there's that one. All right, now for the really fun one. Factor using synthetic division. Okay. Now, the first thing you may notice is I didn't give you any possible factors. And you're looking at this, well, gee, it's a trinomial. I should use PS2, right? Well, here's the problem. This is x cubed, and this is x to the first. In order to be able to use PS2, the slide, grouping, anything like that, is you got to make sure that these exponents are divisible by 2. They're not. So I can't use those earlier methods. Okay? So first thing I have to do with something like this is we have to consider our possible factors. So we're basically going to list all the things this could be. Now, how I teach my students is, again, it's plus or minus factors of the back over factors of the front. Okay. So let's take a look. Let's look at the front. Our coefficient is 1, so it's 1 and 1. So nicely enough for us in an example like this, we're only going to have 1 plus or minus, it's with 1. But let's say, for instance, like say this was a 2. Let me quickly do that so you can see what you would do here. Or, yeah, we'll do a 2. So my possible factors, oops, that looks awful, would be a 1 and a 2. So in that case, since you have 1 and 2 as your factors in the back, or factors of the front, you would do something like this. And then just list your factors of the front on top, and then reduce if you can. Okay. But nicely enough for us, we don't have that here. So my factors are 1 and 1. So I just have to do 1. Okay. All right, now we do the factors of the back. So multiples of 6, 1 and 6, 2 and 3. So we have 1, 2, 3, 6. Okay, so now I look at this. So your possible factors, so it's plus or minus, so 1 over 1 is 1, plus or minus 2 over 1 is 2, plus or minus 3 over 1 is 3, and 6 over 1 is 6. Now, like I said, if you had the over 2, okay, so let's say we had the over 2 as well, then you do 1 over 2 is a half, so you list plus or minus 1 half. 2 over 2 is 1, 3 over 2 is 3 halves, and so on and so forth. Okay? Now, not to be confused, these are not your answers here. Let me fix this. These are not your answers down here. These are all the possible factors we have. These are not the actual factors. So this starts setting me up for synthetic division, and we haven't even done anything yet. Okay? So now that we have this, now we start looking to set up for synthetic division. So the first thing we're going to do is we're going to look for gaps. Now what I mean by gaps is, again, your exponent should be in proper descending order, which means your exponent should go count down. So 4, 3, 2, 1, 0. In this case, notice how we go from 3 to 1 to 0. We got a gap where the x squared should be. Okay? So what we're going to do is we are going to fill that gap with a 0. So we're going to do x cubed plus 0x squared minus 7x minus 6. Okay. Now, once we do that, now we grab the coefficients. Okay, we're not interested in the variable. We want the coefficients. We have a 1. We have a 0. We have a -7. And we have a -6. Okay. I'm going to kind of shrink this a little bit here so we have room to work. Then what we're going to do is we're going to make a box. Okay. And I'm going to put my summation line here. Oops. Okay. Now here's what we're going to do. We're going to start grabbing our possible factors in order to make this happen. Now the catch is, in order for it to be a factor, our end result, so once we get to the end here, it has to be a 0. Okay, because there's a factor theorem rule that says for it to be a factor, your remainder, which is what the last piece is in synthetic division, has to be a 0. Okay, it's that simple. So that's what we're aiming for. If we don't get a 0, then the number's not a factor, and we have to start the process. Not completely over, but that eliminates a possibility. Okay, so let's start. I'm going to pick one that doesn't work. Okay, so we're going to use a 6. I'm going to use a positive 6 inside the box. Let me erase that. I don't like that. So I'm going to use a positive 6. Now, this is a solution, what's in the box. It means its factor is the opposite sign of, so x minus 6. Now, that might be your possible factor. This would be the solution, okay? So what we're going to do is something called ricochet multiplying, or I call it ricochet. So what we're going to do is we're going to send the 1 across the line. Okay. Now we're going to multiply this. So we're going to take the 6. We're going to times by the 1. Now 6 times 1 is 6. Now normally we put the answer, say, underneath the 1. That's not how this works here. We're going to ricochet that under here and put the answer here. And then we're going to add down. So 0 plus 6 is 6. Then you have to do this again. So we're going to do 6 times 6, which is 36. Add down, we get 29. Okay. Then at this point, we have to do it one more time. So I'm going to do 6 times 29. And when I ricochet that, 6 times 29, 4, carry 5, it'd be 174. So when I add down, I'm going to get 168. That's not the 0 we want. So kind of a thing my students ask me, well, gee, if I'm going through this and I notice like my numbers are getting big and I'm not going to get to 0, do I have to keep going? I would recommend not. Okay, so now that we know that positive 6 doesn't work, so I got to get rid of all this, and that's the aggravating part about this process. You're going to do you may do a lot of erasing if you're awful at guessing. Okay, now what I suggest doing is we tried one, let's try the other. Let's do negative 6 just to see if it works. Okay, so we're going to ricochet again. Bring the 1 down. 6 times negative 1, negative 6. Add down is negative 6. 6 times 6, negative 6 times is positive 36, which again is 29. So since I know this is not going to work, I can stop right here. Now, why I suggest doing both factors, even though you know one of them didn't work, is because now that eliminates 6's as a possible factor. So I can get rid of the 6 here. I know it doesn't work at all, so it's gone. I can get rid of it. It's not even a chance now. So it narrows the field a little bit. Okay. Now, kind of a thing my students say is, well, gee, what I usually do is I start with 1. Okay, so let's start with 1. Okay, so let me get a color here. Let's do positive 1. That means x minus 1 would be the factor if this works. So let's begin. 1 times 1 is 1. Add down is 1. 1 times 1 is 1. So negative 6. Oh, we're looking okay. 1 times negative 6 is negative 6. Oh, so close, that's negative 12. But we got closer. So let's clear that out. All right, so we know positive 1 doesn't work. Let's try negative 1. So that means positive 1 would be my factor, and we do this again. So 1 times negative 1 is negative 1, negative 1. Negative 1 times negative 1 is positive 1. Add down, we get negative 6. Negative 1 times negative 6 is positive 6. 0. Yay, that's what we want. Now, the big key thing here is we want to break this down till we have 3 numbers. So 1, 2, 3, and the remainder, which is 0, which is not going to play into it. Because once we have this down to 3 numbers, what this really says is this is x squared, x, and my constant. Things I can factor already before, okay? So I'm going to take this out of the synthetic now. So I'm going to say, well, don't forget this guy. We've already got this one. So that's going to be our x plus 1. Now I'm going to take this down. This says x squared minus x minus 6. Okay, now I look at this. Well, that's easy. That's a PS2 problem. I can do that in my head. So x plus 1, that stays. That's from right here. So now let's PS2 this. So 2 numbers that multiply to 6 but subtract to negative 1 are x minus 3 and x plus 2. And there it is, right then and there. Again, a lot of fun synthetic division is to factor it, but again, it gets pretty tedious and awful, especially if you're awful at guessing numbers. But I'm sorry, but that's how this works. All right, so that's the end of this video. That's pretty much all the factoring that you will see through Algebra 1 and Algebra 2. So again, hopefully you learned a lot from this video, and I will see you next time.